All right, so we're going to move on to the next section, 10.2, which is about the chi-square test of independence. There's going to be a lot of similarities between the chi-square goodness of fit and the independence. It still has 5 steps. There's no parameter like the last one. The way the chi-square value is calculated is exactly the same. The biggest difference we're going to have here is one, we're usually going to have more fractions in our chi-square. HO and HA are going to have a slight variation to them, but luckily it's always the same, unlike the goodness of fit where we have different types. There's only one independence test. And lastly, the expected values are much more annoying to calculate. Aside from that, pretty much everything else is the same. So let's go ahead and read the problem. It says the marketing consultant for a travel agency wants to determine whether certain travel concerns are related to travel purposes. The contingency table shows the results of a random sample of 300 travelers classified by their primary travel concern and travel purpose. Assume that the variables travel concern and travel purpose are independent. Find the expected frequency for each cell. Well, we're going to do the test too. But that's fine. So first thing we do is HOHA. But before we get into that, I want you to notice that there is a difference between this table we have here and the tables we're dealing with in 10.1. And the big key thing that we have that's different is the fact that we have 2 variables. So we have one variable here and one variable here. We have the travel purpose and the travel concern. In the last section, you'll notice that we only ever had one variable, such as the color, or how people got their taxes done. In this one, there's 2 different variables happening at the same time. So that is the dead giveaway to, this is a 10.2 problem, not a 10.1 problem. If you have one column or one row, that's a 10.1. If you have more than that, you have 2 variables, that's a chi-square test of independence problem. So we're going to start with HOHA like we always do. So HOHA is going to be a little bit different here. So HO is going to be the 2 variables, so let's name them. Travel concern and travel purpose. So you write down the 2 variables, the order you write them does not matter, and then you state are independent. And that's it. So we always assume that the 2 variables are independent. Excuse me, there are other ways you could write this. We could say that travel concern and travel purpose are not related. There is no association between travel concern and travel purpose, but for what I always do, I always say they're independent, since it's the test of independence. So assume they're independent. And then HA. HA is going to be so list 2 variables again, travel concern and travel purpose are not. They are not independent. You don't need to capitalize it, but I'm trying to emphasize the fact that HA is always not. A lot of people get those 2 mixed up. So HO, they are independent. HA, they are not independent. Okay, so now we're ready to find our chi-square value. In order to find the chi-square value, the first thing I need to do is find my expectance. So this is where things get a lot more annoying for us. There is just a lot more that you have to do for these problems that you did not have to do for the other one. So the first thing you have to do is you have to find every row and every column total, and of course the overall total. So I need to add the first row, and then I need to add the second row, and then the columns. So the first row is the business row. We have 36 plus 108 plus 14 plus 22 is 180. And we can do the same thing for the second row. So 38 plus 54 plus 14 plus 14 is 120. All right, so I have 180 as the row total there, and 120 as my row total there. So now I need to do my column totals, which I'll do that really quick. So we have 36 plus 38, 34. 108 plus 54, 162, 28, and 36. Okay. So we had 74. We had 162, 28, and we had 36. So let's find all the row and column totals first. And the overall total, 18 plus 20 is 30, so that's going to be 300. It also says in this problem 300 up there, but it doesn't always say the total, so you add them up yourself. All right, so we have all our totals. Excuse me. So the next thing we need to do now is find the expected. So let me write the formula out to find the expected. So your expected value for this is the row total times the column total divided by the overall total. So it's not a hard calculation. It's just a tedious one because we have to do this for every row and every column. So we have 8 cells, so we have to do this 8 times. So that is the tedious part. So you take the row total times the column total divided by the overall totals. Let me show you how this works. So first thing I want to do is find the expected value for business and hotel room. So what is the expected value that's going to go with 36? So what I have to do is take the row total, so all the business, which is 180, times the column total, which is 74, divided by the overall total, which is 300. So we're going to do 180 times 74 divided by 300. I'm going to do all that before it gets really messy. So 180 times 74 divided by 300. So I'll write out the first one. That's a pretty bad one. All right, so let's do that. We have 180 times 74 divided by 300. So that's the row total times the column total divided by the overall total, which is 44.4. And that's our first one. We have to do that 7 more times. So for business legroom, the 108 right here, we have to take that row total, which is the 180, times the column total, which is the 162, divided by the overall total, which is 300. So let's do that. Let's write it down first. So it's 180 times 162. So 180 times 162 divided by 300. So 180 times 162 divided by 300 is 97.2. So that is the expected value for the legroom business. I'm going to do the whole business row, but after that, I already have these calculated, so I'm not going to do all the math for the other ones. Hopefully you're seeing the pattern here. So for rental car size business, that's 14 right here. I'm going to take the row total, 180, times the column total, 28, divided by 300. That'll give you the expected, so I'm going to have to work. So it was 180 times 28. So 180, oops. 180 times 28 divided by 300. And that is 180 times 28 divided by 300, 16.8. And then my final one, which is going to be for the 22. Oops. I should erase these first. Okay. Let's try the 28 again. All right, so for the 22, we have to do 180 times 36 divided by 300. That's the row total and the column total for the 22. The business other. So 180 times 36 divided by 300. Okay. 180 times 36 over 300. So 180 times 36 over 300. And that is 21.6. So these are the expecteds for the first row. I still have 4 more to go. So you would just continue doing this math to get the expected for the other one. So all of these will stay the exact same, except that the row total now is going to be different. So now I need to use the 120 instead of the 180. It's still going to be 74, 162, 28, 36. It's just now this would be 120, this would be 120, this would be 120, and then this would be 120. So the calculations are the same. You just switch the rows and the column totals. Right. So those come out to be 29.6, 64.8, 11.2, and 14.4, which are going to pop up in the calculation anyway. So I'm not going to write those down just yet. But if you want to calculate those yourself, it may not be a bad idea to make sure you do understand what's going on here. All right, if you've chosen to do that or not, either way, I'm going to erase all of this so I can just get some more room here. Once again, I already had the expected written down. I was just showing you how to get them. So just like before, when you're showing your work, you only really need to do the first and the last one. You don't have to do all 8. Because it just becomes really tedious work. So chi-square is still going to be the observed minus the expected squared divided by the expected. So that's not changing. And we just have to do it. So chi-square is going to be equal to my first value. If you wrote down the table, I'm not going to keep scrolling up and down the whole time. It's just going to be too much work. I have it written down next to me. So the first one is 36 minus the expected, which was 44.4 squared divided by the expected, plus 108 minus 97.2 squared divided by 97.2 plus, and we keep doing this. I'm not going to write these all out. If you knew how to do the 10.1 stuff, this is no different anymore. At this point, everything is the same. I will write the last row just so you can see all the expecteds, but I'm not going to write the next 2 in that one. So the next row starts with 38. The expected was 29.6. So 6 squared divided by 29.6 plus 54. The expected for that was 64.8 squared divided by 64.8. The next one was, goodness, I'm sorry, 14. The expected was 11.2 divided by 11.2. And our last one was 14 minus 14.4 was the expected divided by 14.4. I'm not going to type this all in the calculator once again. If you were getting the other stuff, you can type it in. The typing in is not hard, it's just tedious. So whatever calculator you're choosing to use, type that in. The answer comes out to be 8.158. So that is our chi-square value. Like I said, it's really the same thing. We just have to do the expected a little bit more annoying, and there's usually more fractions. Once again, I'll try and keep the fractions down. I'll try not to give you a table that has like 15 fractions in it. I'll try and keep it 9 or less. I can't. It should be. I don't think anything more than 9. So I'll try and keep them small for you so it's not real bad. All right, we have our chi-square value. Now we need degrees of freedom. Degrees of freedom is a little different here. You can't just do the number of categories minus 1. So let's find our DF here. So to find the DF, you take the rows minus 1 times the column minus 1. So you count the number of rows, take away 1, count the number of columns, take away 1, and multiply those two. It doesn't matter if you switch the columns and the rows. Multiplication is commutative. So if I count my number of rows, I have 1, 2 rows, business, leisure. If I count the columns, I have 1, 2, 3, 4 columns. So we have a 2 by 4. So my DF is going to be equal to 2 minus 1 times 4 minus 1, which is equal to 3. That's 1 times 3 is 3. So we have 3 degrees of freedom. So then let's find our chi-square. So probably that chi-square sub 3 is greater than, I think it was 8.158, yep, 8.158. And we're going to go to our chi-square calculator again. So chi-square was 8.1, whoops. Chi-square was 8.158 with 3 degrees of freedom. P-value 0.04286. 0.0, I forgot already, 4286. 4286. Now, there was no alpha given in this problem, and it does matter because we have a borderline. The problem itself, I copied the wrong problem down. It's giving an alpha of 0.01. So this is going to be a fail to reject. So let's write our conclusion. So since my p-value is greater than alpha, I fail to reject HO. And just like the last one, you just write HA again. You either have evidence HA is true or you don't have evidence HA is true. And if failed to reject, you don't have evidence. So there is no evidence that, just look at the variables again, travel concern and travel purpose. There's no evidence that travel concern and travel purpose are not independent. All right. So make sure that just like before, we're writing about HA, and HA is not. So if you say they are independent, you will be wrong. So there's no evidence that they are not independent. It doesn't mean they are independent. It just means we can't disprove that they are. We can't prove that they're not. All right, so that is the chi-square test of independence. Aside from being tedious, it is very similar to the last one. Excuse me. So hopefully you won't have much problem with this. On my assignment, I've only assigned 3 problems this time instead of the 4, just because, 1, they're all the same type of problem. We don't have the 2 different types. And 2, they can be a little bit more work. Let's just recap really quick before I end the video. Remember, HO is always the 2 variables are independent. HA is always the 2 variables are not independent. To find the expected, you're going to find every row total, every column total. And then you take the row total times the column total divided by the overall for each of the cells. So whatever cell you're in, say you're in the legroom leisure, that 54 there. So for that 54 there, you take the column total times the row total, or the row total times column total, doesn't matter. So just go down, go over from that point, times those two, and divide by the overall total. Do the chi-square the same way we did, expected, or the observed minus the expected squared divided by the expected. Your degrees of freedom is the number of rows minus 1 times the number of columns minus 1. And remember, this is always an upper tail test. That's why I did a greater than, but the p-value calculator does it for you. And remember, lastly, that your final sentence is written about the alternatives. So it will always say are not independent. The only thing that's going to change for you is this word here. Either there is evidence or there is no evidence. That is literally the only word difference. All right. Hopefully that simplifies everything for you. Now you know how to do these types of problems. If you have any questions, please either send me a message on Remind or go ahead and post something on Teams. We'll have the exact same assignment. You'll have one written assignment and one quiz, just like before. All right, hope everything's going well, and I'll look forward to putting up another video next week. You all have a great day.